एक Dr. Naveed Sharwani, Chief Guest, Chairman and CEO, FPGA Foundation. Engineer Dr. Javed Yunus Uppar, President, IIP, Karachi Center. Engineer Professor Dr. Ataullah Khwaja, Chairman, Department of Electrical Engineering, NED University, and co-convener IWC 2022. Engineer Dr. Muhammad Mohsin Aman, co-chairman, Department of Electrical Engineering and Industry Engagement Secretary, IWC 2022. Engineer Asim Murtaza Khan, President, NED and International Alumni Network Association, Pakistan. Engineer Amir Zamir Ahmed Khan, Secretary General, IEP. Dr. Abdul Ghani Ablo, Conference Secretary, IWC 2022. Engineer Farooq Arbi, FIEPE, Secretary, IEP, Karachi Center. Distinguished guests, esteemed authors, presenters, ladies and gentlemen, Assalamu alaikum and good afternoon. On behalf of NED University of Engineering and Technology, Karachi, it is my proud privilege to welcome you all to this inaugural session of the 7th International Electrical Engineering Conference 2022, jointly organized by the Institution of Engineers, Pakistan, Karachi Center, and NED University in collaboration with various universities from Sindh and Balochistan and national centers. To begin the inaugural session of the conference, I request Hafiz Ahmad Ashraf to please come forward to recite few verses from the Holy Quran. Jazakallah. मैं तो बोल लूंगा लेकिन बाकी लोगों की आप लाउडेंस में वो नहीं कर सकते ना, हाइट डिफरेंस भी तो आता है. अच्छा, मैं वैसे इस हिसाब से स्लो बोल रहा था. ठीक है. Ladies and gentlemen, you are now requested to rise for the national anthem. Ladies and gentlemen, you are now requested to rise for the national anthem.
The guests may now take their seats. Thank you. This is Nida Gul, student of Final Year Electrical Engineering Department, NED University of Engineering and Technology, co-host of this event. Ladies and gentlemen, this 7th International Electrical Engineering Conference is a regular feature in the series of conferences being organized by the Institution of Engineers Pakistan, Karachi Center, and NED University. To proceed with the session, I will request Engineer Professor Dr. Saad Ahmed Qazi, Dean Electrical and Computer Engineering, NED University of Engineering and Technology, and convener conference to give a briefing on the 7th International Electrical Engineering Conference. Thank you, Dr. Saad Ahmed Qazi. Ladies and gentlemen, Ladies and gentlemen, now I request Engineer Suhail Bashir, Chairman, Institution of Engineers Pakistan, Karachi Center, for his welcome address. Thank you, sir, for your welcoming notes. Ladies and gentlemen, today we have with us a very experienced researcher, professor from University of Oulu, Finland. His major microscopy, nanofabrication, and biomedical engineering. He has recently received nearly 2 million euros funding. He is currently building the state-of-the-art R&D labs for advanced electronics and energy systems at University of Oulu. It is my pleasant duty to invite Mr. Syed Gufran Hashmi online to present his keynote address. Thank you, sir. Thank you for your informative keynote speech.
Ladies and gentlemen, today we have with us postdoc research fellow Dr. Hassan Beg from University of Connecticut, USA. He is currently working on the development of cloud-based computational tools for system biology. He worked on a future emerging technology in the domain of design automation for synthetic biology and also developed methods, algorithms, and tools for the analysis, verification, and synthesis of genetic logic circuits. Unfortunately, he cannot join us at the moment, but he has sent his recorded keynote speech. Now we request to Mr. सर एक दफा इनकी चला भी दें ताकि वो हेलो हेलो सर आवाज आ रही है हेलो
Hello, hello, check, 1 2. Hello, hello, check, 1 2.
हेलो सर हेलो 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 एम आई ऑडिबल सर आपको
Hello, hello, check, 1 2 3. Hello, 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 check, 1 2. Hello, hello, check, 1 2. Hello, 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 check, 1 2.
ओके अब जो है वो आवाज आ रही है
Hello,
अब मेरी
check, 1 2 3. Hello.
अब आवाज आ रही है
Hello, check, 1 2 3. Hello, hello,
आ,
check, 1 2 3. Hello, hello, mic check, 1 2.
मुझे तो आवाज आ रही है आपकी ना वहां से इस मोबाइल के थ्रू मुझे आवाज आ रही है आपकी लेकिन मेरी आवाज आ रही है आपको ये बताएं ठीक है आवाज आ रही है हाँ अब आ रही है आवाज हाँ हाँ तस्वीर आ रही थी आवाज नहीं हाँ अब आ गई ना वहां पे अब सही है मेरा ख्याल है अब ठीक है ना
हेलो
अब मैं
हेलो
यहाँ
सर
पे
आपको
यहाँ
आवाज
से
आ रही
स्पीच
है
करना शुरू कर दूं
हेलो
हेलो
सर आपको आवाज आ रही है
हाँ मुझे आवाज आ रही है आपकी लेकिन मुझे आपकी वीडियो नहीं आ रही है
Hello, check, 1 2. Hello, hello, check, 1 2 3. Hello.
मुझे जो वीडियो आ रही है ना वो मेरी ही सिर्फ है
उससे गया उससे हमारे को मैसेज करो कितने बजे हैं
वो देखें ऐसे वाले से हेलो हाँ अब जो है वो मुझे जो है ना वो नजर आ रहा है ये जो बैनर है ठीक है अब मुझे बैनर नजर आ रहा है जो मुझे आवाज आ रही है वीडियो जो चला रहे हैं वो नेशनल एंथम चला रहे हैं अब सही है अब वीडियो खत्म हो गई ओके और कुछ चाहिए जाके मैं बाहर जाऊं बंद कर दूं फहद फहद ओके
Hello, 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 check. Ladies and gentlemen, yeah, hello. बहुत जोर से बोलना होगा इसको. Ladies and gentlemen, today we have with us postdoc research fellow. Hello, hello. यार इसकी पिच क्यों स्लो हो गई है काफी? पिच काफी स्लो हो गई है. हेलो, हेलो, हेलो. बहुत आगे आगे बोलना पड़ रहा है ना. हेलो, हेलो, हेलो. सही है. Ladies and gentlemen, today we have with us postdoc research fellow Dr. Hassan Beg from University of Connecticut, USA. He is currently working on the development of cloud-based computational tools for systems biology. He worked on the future emerging technology in the domain of design, automation for synthetic biology, and also developed methods, algorithms, and tools for the analysis, verification, and synthesis of genetic logic circuits. Unfortunately, he cannot join us at the moment, but he has sent his recorded keynote speech. Now we request to Mr. Fahad Miraj to play keynote speech. भाई सिक्योरिटी को डील नहीं कर, तुम बाहर जाओ. मैनेजमेंट की टीम को यहाँ डील करना है. हाँ, रजिस्ट्रेशन वाले को रूसा डील कर लेगी. हुमायूं, टीम को बुलाओ पूरी. सर दर्शन
Hello, hello, check. 1, 2. Hello, hello, check. 1, 2, 3. Hello, 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 check. 1, 2, 3. Hello, hello, check. 1, 2, 3. Hello, 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 check. 1, 2, 3. Hello, 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 check. 1, 2. Hello, hello, check. 1, 2, 3. Hello, hello, check. 1, 2, 3. Hello, 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 check. 1, 2, 3. Hello, 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 check. 1, 2. Hello, 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 check. 1, 2, 3. Hello, hello, check. 1, 2, 3. Hello, hello, check. 1, 2, 3. Hello.
हसन बे की दे दिन वो डाउनलोड कर लिए ना हेलो 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 आवाज आ रही है ठीक है ये वहाँ जाएगी उनको जो कीनोट स्पीकर
Ladies and gentlemen, we are about to commence with the program. Please be seated. Bismillahir Rahmanir Rahim. In the name of Allah, who is the most beneficent and the most merciful. This is your host, Abdul Rafi bin Khalid, final year student, Department of Electrical Engineering, NED University, Karachi. Respected Engineer Professor Dr. Saroj Lodi, Vice Chancellor, NED University of Engineering and Technology, Karachi. Engineer Sohail Bashir, Chairman, IEP, Karachi Center. Engineer Professor Dr. Muhammad Tufail, Pro Vice Chancellor, NED University, Karachi. Engineer Professor Dr. Saad Ahmad Qazi, Dean, Electrical and Computer Engineering, NED University, and Convener, IEEC 2022. Dr. Naveed Sharwani, Chief Guest, Chairman and CEO, FPGA Foundation. Engineer Dr. Javed Yunus Uppar, President, IEP, Karachi Center. Engineer Professor Dr. Ataullah Khwaja, Chairman, Department of Electrical Engineering, NED University, and Co-Convener, IEEC 2022. Engineer Dr. Muhammad Mohsin Aman, Co-Chairman, Department of Electrical Engineering and Industry Engagement Secretary, IEEC 2022. Engineer Asim Murtaza Khan, President, NED International Alumni Network Association, Pakistan. Engineer Amir Zameen Ahmad Khan, Secretary General, IEP. Dr. Abdul Ghani Abro, Conference Secretary, IEEC 2022. Engineer Farooq Arbi, FIEP Secretary, IEP, Karachi Center. Distinguished guests, esteemed authors and presenters, ladies and gentlemen, Assalamu alaikum and good afternoon. On behalf of NED University of Engineering Technology, it's my proud privilege to welcome you all to this inaugural session of the 7th International Electrical Engineering Conference, jointly organized by the Institution of Engineers Pakistan and NED University in collaboration with various universities from Sindh and Balochistan and national centers. To begin this inaugural session of the conference, I request Hafiz Ahmad Ashraf to please come forward to recite few verses from the Holy Quran. Hafiz Ahmad Ashraf.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم آمن الرسول بما أنزل إليه من ربه والمؤمنون كل آمن بالله وملائكته وكتبه ورسله لا نفرق بين أحد من رسله وقالوا سمعنا وأطعنا غفرانك ربنا وإليك المصير لا يكلف الله نفسا إلا وسعها لها ما كسبت وعليها ما اكتسبت ربنا لا تؤاخذنا إن نسينا أو أخطأنا ربنا ولا تحمل علينا إصرا كما حملته على الذين من قبلنا ربنا ولا تحملنا ما لا طاقة لنا به واعف عنا واغفر لنا وارحمنا أنت مولانا فانصرنا على القوم الكافرين صدق الله العظيم.
Jazakallah. Ladies and gentlemen, you are now requested to rise for the national anthem.
The guests may now take their seats. Thank you. This is Nida Gul, student of Final Year Electrical Engineering Department, NED University, co-host of this event. Ladies and gentlemen, the 7th International Electrical Engineering Conference is a regular feature in the series of conferences being organized by the Institution of Engineers Pakistan, Karachi Center, and NED University. To proceed with this session, I will request Engineer Professor Dr. Saad Ahmed Qazi, Dean Electrical and Computer Engineering, NED University of Engineering and Technology, and Convener Conference to give a briefing on the 7th International Electrical Engineering Conference.
Bismillah ar-Rahman ar-Rahim. Dr. Naveed Sherwani, Chairman and CEO, Global Semiconductors Group. Sayyid Ghufran Hashmi from University of Oulu, Finland. Our keynote speakers. Engineer Sohail Bashir Saab, Chairman, IEP Karachi Center. Professor Dr. Ataullah Khwaja Saab, Chairman, Department of Electrical Engineering. Distinguished guests, faculty members, and students. Assalamu alaikum. And a very warm welcome to the 7th International Electrical Engineering Conference 2022. As you may be aware, we lost a dear colleague and friend, Professor Dr. Syed Usman Ali Shah, Chairman, Department of Electronic Engineering, is no more with us. Inna lillahi wa inna ilayhi rajiun. Dr. Saab has been a great asset to this university and has made tremendous contributions in learning and research during his stay at NED University. Heading the CPEC cell at NED and introducing Chinese language to thousands of students remain one of his several key contributions for this university and the country. Ladies and gentlemen, before we proceed further, I would like to request the audience to take a few moments now and recite for his departed soul and pray for his maghfirah. Alhamdulillahi Rabbil Alameen Ar-Rahman Ar-Rahim Maliki Yawmiddin Iyyaka na'budu wa iyyaka nasta'in Ihdina siratal mustaqim siratal ladzina an'amta 'alaihim ghayril maghdubi 'alaihim waladdallin. Qul huwallahu ahad Allahus samad lam yalid wa lam yulad wa lam yakul lahu kufuwan ahad. Qul huwallahu ahad Allahus samad lam yalid wa lam yulad wa lam yakul lahu kufuwan ahad. قل هو الله احد الله الصمد لم يلد ولم يولد ولم يكن له كفوا احد. اللهم اغفر لحينا وميتنا وشاهدنا وغائبنا وصغيرنا وكبيرنا وذكرنا وانسانا. اللهم من احييته منا فاحيه على الاسلام ومن توفيته منا فتوفه على الايمان. امين يا رب العالمين. As conference convener and in consultation with Chairman IEP Sohail Saab, Karachi Center, I would like to propose that the conference proceedings today and tomorrow be dedicated to the services of Professor Dr. Syed Usman Ali Shah. Thank you very much. This year, Alhamdulillah, we observed a tremendous surge in papers. In total, there were 83 submissions from various parts of the world, including Italy, UAE, Saudi Arabia, and China. After thorough review, 29 papers were selected for oral presentation and 19 were accepted for poster presentations. There will be 6 sessions covering various thematic domains related to electrical engineering under the conference main theme, Aspire. This year, all accepted papers are going to be published in MDPI Journal of Engineering Proceedings, inshallah. I would like to especially thank the authors and participants who have contributed to this conference and have taken out time to present their works during the conference. And I would also like to extend my special appreciation to the program team and reviewers from various universities for going through the review process diligently. It's a tall task given the very diverse submissions from various universities. I would like to extend special thanks to our respected keynote speakers, as well as invited speakers today and tomorrow, who have taken out time to accompany and enlighten us. One of the great things about this conference has been the strong partnership between various universities and National Centers Lab. And I would like to acknowledge your contributions for making this conference a reality. Last but not the least, I would like to thank IEP Karachi section, led by Suhail Saab, for their tremendous support, and the organizing team led by Dr. Abro for putting in hard work for the conference. Thank you very much. And best wishes to all of you for today and tomorrow. On such occasions, as I always say, make new friends, learn new things, and please ensure that when we leave better and richer. Thank you. Pakistan, Zindabad.
Thank you, Dr. Saad Ahmed Qazi. Ladies and gentlemen, now I request Engineer Suhail Bashir, Chairman, Institution of Engineers Pakistan, Karachi Center, for his welcome address.
Bismillah ar-Rahman ar-Rahim. I start in the name of Allah, the most merciful, the most beneficent. Respected Dr. Saad Qazi, Mr. Naqvi, Vice Chairman, Vice President, Chemical Institute of Engineers, Pakistan, and distinguished guests, ladies and gentlemen, and especially all those who have joined us as our partner institutions. Well, today when I was coming to this inaugural session, I heard the tragic news of passing away of one of our very dear and near friend, Engineer Dr. Usman Ali Shah. We have worked together very long, and I found always him a very cooperative and a very noble person. May Allah grant him Jannah. May Allah give him the best place in Jannah. Very rightly pointed out by Dr. Saad that there were two options when we were discussing, because this all happened around Zohar time. So we had an option either to postpone, because we could have postponed this inaugural session, but then we decided that instead of postponing, let's name this whole proceedings as suggested by Dr. Saad in his name, and let honor him by our gathering here. So that's the thing. Moving forward, we were a few of our guests who have come from Lahore. They are in the way. Today also in the Dohar prayers, the sister, there was a funeral of sister of Pakistan Engineering Council Chairman, Engineer Najib Harun, and many of our friends have gone there in Zohar prayers at Clifton to join them. So they are all coming. So because Shah Saab's funeral is in Maghrib prayers at North Karachi, so we thought it fit that instead of waiting for our guests to come, let's start the proceedings, and some of us will inshallah join his namaz-e-janaza in North Karachi. So going forward, the Institute of Engineers Pakistan is proud to have a partnership with NED University and other partner universities and other institutions for arranging conferences. And this is the second international conference of this year. Previously, we had Mechanical Engineering Conference and Electrical Engineering Conference. We started in 2016. And now we have reached 7th internationals and without any break. That's a commendable job, and I salute all the faculty members of especially all the faculty members of the Electrical Engineering Department of the NED University and all the partners universities for their patronage, help, assistance, and everything for this conference. And then, as customary, I used to say that Institution of Engineers Pakistan, the sole purpose of Institution of Engineers Pakistan is dissemination of knowledge. And for dissemination of knowledge, we have we have arranged many symposia, colloquium, and conferences. And this electrical engineering conference is one of its kind, which we held every year. And similarly, we also have a mechanical engineering conference and civil engineering conference. But this year, this is a unique year that we are going to have 4 new conferences. And one of them is the first International Biomedical and Digital Health Conference. The chairperson of the biomedical engineering is sitting here, and we have discussed a lot on this, and we have got a very good response. And this particular conference emerged after the COVID-19 scenario, and a lot of things have been carried out in the digital health, and probably this will be the first conference in which the engineers, the doctors, and the pharmacists, they will all join together for this particular conference. So I look forward, and that conference is going to be held on 17th and 18th of June 2022. Prior to that, we will have the 12th International Civil Engineering Conference, which we held on 9th and 10th May of 2022. Then we have upgraded the national conference to the International Conference on Health, Safety, and Environment, and that will be held on 2nd and 3rd September 2022. And again, a very important topic, the UN SDGs. So there will be a conference on international UN SDGs on 28th and 29th of October 2022. And then with the help of the materials and department of NED University and other universities, we will be having the 4th International Conference on Advanced Materials and Process Engineering on 2nd and 3rd December 2022. So the complete 22 is busy, and beside that, we will be having many webinars during the course of the time. So I would like to take this opportunity to thank all the participants and look forward for very good and interesting tomorrow's 6 sessions, where we will hear very good and important papers. Thank you very much.
Thank you, sir, for your welcoming words. Ladies and gentlemen, today we have with us a very experienced researcher, Mr. Syed Gufran Hashmi, Assistant Professor from University of Oulu, Finland. His major skills are in solar cells, printed electronics, microfabrication, nanomaterials, spectroscopy, nanofabrication, and biomedical engineering. He has recently received nearly 2 million euros funding. He is currently building the state-of-the-art R&D labs for advanced electronics and energy systems at University of Oulu. It is my pleasant duty to invite Mr. Syed Gufran Hashmi online to present his keynote address.
Thank you so much. Can you all hear me? Okay. And let me share my screen quickly. So hope you can all see it now. Can somebody endorse that? Are you listening to me? Okay, sure. Thank you so much. Assalamu alaikum, everyone. And thank you so much for providing me this wonderful opportunity. And because I am loaded with a lot of slides, so I will not waste any time further. So let me introduce myself. My name is Syed Gufran Hashmi. And I did my graduation from Sir Syed University, and after that I did my master's and then my PhD from Alto University, and I remained there for more than a decade. And from May 2020, I have joined University of Oulu as a tenure track assistant professor. And I was thinking that, okay, what to present to this conference, and because some of the researchers and scholars in recent past have contacted me to work on this one of the established and also like emerging area of science and technology. So I thought that it's good to give a talk about this solar cell technology. So before I go to the original topic, as many students have been listening, and watching. So I recommend that in order to start, if somebody wants to start to work on a solar cell technology, so it's always good to see the state of the art regarding all the established technologies that have been produced and reported. So this is like one of the quickest way. And then it is a chart that is often updated by NREL. So anybody who wants to get to know about the current state of the art regarding the escalating conversion efficiencies, so they should watch and keep observing this chart. Another way is that this efficiency tables have also been regularly updated by a group, and they also sometimes like they frequently update this conversion efficiency tables. So anyone who wants to work, so they should also keep following these conversion efficiency tables. So there you can see a lot of technologies, and both the lab size devices and also like sometimes they also update with the module based conversion efficiencies. So now I come to the topic, which is when I joined this university, so its colorful campus was a great motivation for me, where, as you can see here, it is loaded with full of colorful walls. This is like the student housing, and as well as some of the internal architecture and built environment within the university. So why is that? Because there is a very good synergy with these colorful buildings and also like the dye sensitized solar cells, where you can see that different colors of cells, and it can be produced in variety of ways. So without wasting much more time, I would also emphasize about the basic components of a dye sensitized solar cell, which is, as you can see here, so it is basically the traditional embodiment is comprised of two glass based substrate, and in between that there are plenty of materials are enclosed, such as semiconducting oxide layer, preferably titanium dioxide nanoparticle based film that is used to promote the electron conduction, and then it is sensitized with a dye molecule. Traditional dyes are ruthenium based sensitizers, and then we have an electrolyte that exchange the charge transfer occurs through it, and then also both electrodes remains separated with a gasket with a thermoplastic, and then we have a catalyst layer that is also coated on the similar transparent conducting oxide glass substrate. So all these components have been tremendously researched in past 3 decades, and where every individual component, such as photoelectrode, which is comprised of, as I mentioned before, semiconducting oxide layer, preferably titanium dioxide, but also zinc oxide and tin oxide. So many composites, and also the fabrication schemes have been proposed. Similarly, now there has been a lot of research made on different classes of dyes, and now various classifications of dyes have emerged, as you can see in this slide, and that offers like variety of colors as well. So it is possible to design some kind of colorful architectures based upon the available opportunities. In the same way, the electrolyte research has also progressed very well, and where according to the challenges and the advantages of various ingredients of these electrolytes, so they have been tested in variety of combinations of dye sensitized solar cells. Similarly, in this catalyst research, for example, the traditional dye sensitized solar cell was having platinum based catalyst layer, which is considered as one of the expensive components. So that can also be replaced with far cheaper material, for example, carbon-based catalyst layers and composites of carbon. So which also offers like variety of characteristics, as you can see here. So as a brief overview about the operating principle of dye-sensitized solar cells, as I showed you that its traditional embodiment is comprised of two electrode-based geometry. So one contains a semiconducting oxide that is sensitized with a dye. As you can see, I can even show you quickly. So before sensitization, it looks like this when you print a titanium layer. And after sensitization, it turns into red through the anchoring groups. And then a monolayer is formed like over. So then you can have like colorful dyes to sensitize your photoelectrodes. And what happens that in a range of let's say picoseconds to milliseconds time interval, a series of reactions occur where, like, upon receiving of sunlight energy, the molecule of dye gets excited, and then it moves. The electron moves from HOMO to LUMO level, like lowest unoccupied molecular orbital, and where it gets injected into the conduction band of titanium dioxide, and that receives and transports it to the transparent conducting oxide coating, and then it is fed to the external circuit or load, and then it is received back by a counter electrode, which is comprised of a catalyst layer, and then the excited dye at the photoelectrode side gets regenerated by through a redox couple. The traditional electrolytes were having iodide and triiodide based redox couple. So this iodide ion gives an electron that reduces the dye back, which is, we call it regeneration, and then the triiodide, the iodide ion gets converted into triiodide and moves towards the counter electrode, where it receives that electron that is transferred through the load and reach to the counter electrode, and then it also gets reduced. So this process like occurs rapidly under this kind of as you can see here in this slide. So from the as I mentioned before, from the magnitude of picoseconds to microseconds, and when the dye gets excited and then the electron gets injected into the photoelectrode, so it can also recombine with the triiodide ion, and that is also called like the back reaction or dark reaction. But luckily, this injection and transference is like more rapid than the recombination process. So that's why a decent amount of current densities can be achieved. And you can characterize the solar cell. This is like some general rules and then characterization methods, that through the electrical, optical, and also electrochemical impedance spectroscopy based characterization methods, where these different components form different interfaces, and that interfaces allows us to build this resistive and capacitive combination. And with the technique developed, it is called electrochemical impedance spectroscopy. So you can observe the individual interface behavior and its resistances, and then you can also work on individual component in order to reduce the overall losses and also like some of these resistances. So because, as I mentioned in the beginning, so there are many components that have been proposed in recent years. So that allows to fabricate the device design into many configuration on variety of substrates. Although the traditional embodiment was proposed on glass substrate, however, after this material science progress, so it has been also demonstrated on flexible polymers, conducting polymers like ITO-PET or ITO-PEN foils, and also like the metal electrodes such as titanium metal foil, or even far cheaper stainless steel based substrates. So even the scalability and also like the demonstration of upscaling and even integration into many buildings and also like in this kind of built-in environment have been demonstrated, But then the question is that why it is stopping a wide spread of DSSC technology even after an intense research. So the answer is there have been many challenges and limitations observed because it's a great combination of variety of materials. So making a chemical balance and chemical stability and also sometimes mechanical durability is quite challenging. And for example, liquid electrolyte are also very, very sensitive to the UV light that is a constituent of one of the constituent of sunlight. And also like, these redox couples are also found very corrosive to some of the metal substrates. So that's why over the period of time, they get corroded. And in order to compare with the existing technologies such as silicon-based photovoltaic, panels, for example, if you go and buy, so you get around 20-25 years of warranty. So in order to compete any existing benchmark, so your materials or your whole embodiment should provide the same robust device stability if you want to compete with the existing technology. So these are like some of the protocols presented in these two publications. I would recommend if somebody wants to probe it in order to understand what are the journal stability testing rules. So they should go through these articles where like some standardized testing, accelerated testing, both in the simulated and outdoor condition environment have been proposed, where the researchers can get an idea that how to test your fabricated devices, both at the lab size scale and also like at the module scale. So if we look very quickly, the latest kind of state of the art regarding the photovoltaic performance. So here, as you can see here, so the solar cell conversion efficiencies are ranging for the dye sensitized solar cells in between 8 or 9 to 12%, let's say. And with this mini module size or sub module size, it is even like far lower than the newly emerging technology called perovskites, where even at the module or mini module level, a conversion efficiency of let's say around 20 to 22% have been reported. So not only the limitation with the conversion efficiencies when you scale up the technology, and also like these stability challenges have been realized in this established field. Nevertheless, we have an interesting case, as I mentioned, that even in this electrolyte, so there has been not only the traditional redox couple such as iodide or triiodide ion was introduced, but also the alternative redox couple such as cobalt based redox shuttles are also nowadays. Some copper complexes have also been produced, and which allows us to achieve like very high open circuit voltage. If you see here the redox potential, so it is with the iodine, it is like it was very difficult because it remains in between the HOMO and then the Fermi level, but over the period of time it has nicely shifted towards this HOMO level. So now there is a very good gap which allows us to achieve like even more than like 1 volt. So that has generated some very good interest in the field, where instead of outdoor applications for bulk electricity generation, so you can also harvest the indoor light. If you compare here, for example, in this slide, as you can see here, so under different kind of climatic conditions outdoor, so we achieve like a range of lux intensities, like range from 10,000 to under full sun when there are no clouds, so around 100,000 lux. But compared to this outdoor climatic conditions, we have also like indoor environment in indoor environment you can see at various places. So you have living room, even like some supermarkets, so they allow different kind of lux light intensities. So I present a very interesting case here. As you can see here, if you can see, so a small rotor is powered up through a dye sensitized solar cell, which is like getting a light energy from a lamp. And since like, for example, I'm located here at Oulu, so at peak winters, we observe like a day of just 6 hours and a night time of almost 18 hours. So I assume that this grid electricity gets significantly consumed in order to energize all these artificial lamps. So the one of the motivation is, can you really regenerate this light as a free energy source, and can you harvest this light in order to power up this futuristic IoTs based application? Because at the moment they are having batteries in it, and making them sustainable kind of gadgets is a great challenge. So this video gives us a motivation. So based upon that, and then this new redox couple based kind of embodiments, so very interesting research results have been presented by some of my dear colleagues, where you can say that it's possible to generate efficient power under these low lux light conditions. And then it is demonstrated in many of these articles that you can really energize a few electrical nodes, and also like some other kind of portable devices. So, and also with that, as you can see here on the right side, that there are some liquid. So when you inject a liquid electrolyte, so it gets evaporated if you don't seal the cell. And then it was found that even if the solvent of the electrolyte gets evaporated, so it's still like the solid mass of the electrolyte that remains in between photo and counter electrode. So you can still get the photovoltaic response of the solar cell. So that is called also like the zombie cells. And it is like almost converted to a solid state dye sensitized solar cells. So that also allowed to directly make a contact with the counter electrode without utilizing a gasket. And then if you even inject an electrolyte, so then it is still like functions. So based upon this device design, so the diffusion resistance that we observe as through the interelectrode distance between the electrodes, so that was suppressed, and then allowed to not only to get a very good conversion efficiency under full sunlight intensity condition, but also under ambient light, very impressive conversion efficiencies have been demonstrated. And even now this voltage, which I showed you in the earlier slides, that is possible to achieve 1 volt, but now even more than 1 volt, and now it has reached to 1.24 volt. So you can go all these articles provided through the references. And in all these new devices, as I mentioned, so or even the traditional device, so we had like this traditional platinum catalyst, but all these alternative devices are remain compatible with an alternative catalyst layer. It is called PDOT based conducting polymer, so that you can also like coat on very large scale, and that has been like remain like most active with these alternative redox couples compared to platinum. And I have also been working since many years with this carbonaceous counter electrodes. So that made me that motivated me to test these counter electrodes, which I had tested with iodine based electrolytes, to also like test it with this newly introduced copper based redox shuttles. So as a quick test, we first reported here this printed single wall carbon nanotube based counter electrodes, which was a commercial paste, and is a low temperature paste which you can coat like both on flexible and also like the glass based substrates. And we were very happy to see that in our quick testing we achieved very promising, not on the full sunlight intensity condition, but also if you reduce through a light transmitting filter. So under half sun, like, it was around 8.3% in the lab size devices. And where we compared the performance with this platinum catalyst with our new single wall carbon nanotube based counter electrode. So then you can see a great magnitude in the difference of impedance with the traditional platinum catalyst and also like the alternative catalyst. So the overall impedance was greatly reduced, and thus allowing us like to achieve like good performance. But also if you make the inter electrode distance slightly like higher, so that it induces like a great diffusion resistance. So that is also like a challenging situation, that okay, how to optimize that interelectrode distance between photo and counter electrode with these redox couples. So we have also presented some of the results by showing some electrochemical response of making the symmetrical cells of the counter electrodes. And there you can see here again that how the platinum based counter electrodes are showing great or high, very high impedance compared to the carbonaceous counter electrode. So this is like far cheaper, composed of carbon black and also like the graphite nanoparticles. And this was also like printed paste, which we used for both in order to have a fair comparison. And these low-cost carbonaceous catalyst material are also looking very good, where we achieved 6 to 7% devices. And most importantly, we were able to also present some long-term stability test under like very this mild conditions, indoor conditions, and the performance remained like very stable. So that gives an idea about the chemical compatibility of carbonaceous material. So some quick initial learnings is that, I mean, these materials can be used as an alternative substitute to the traditional platinum or even now this P dot based counter electrode. And also they remain like, very compatible when you run the performance and also analyze the performance for longer period of time. And then like it is also enabling to achieve like very good catalytic activity with a very reduced charge transfer resistance to achieve like high efficiency. So some more dopings can be done, or some more kind of composites can be formed, which we have tested before. So we are working on that as well. And why, the question is why I'm more interested in using the printed carbonaceous counter electrodes, because if you see like all these journal embodiments with copper electrolytes, so it's a 2 electrode based device, which already not only keeps the big and like thicker in size, but also like induce the cost additions, because in whole this kind of device design, the majority of the cost comes from the substrates you use. So that was a motivation for me. And then in a very recent article, which is very well received by the community, so we propose an alternative way that you can, on a single glass substrate, you can really print all the active layers, and you can like come up with a really like a novel solid state device design. So in order to facilitate that, we had already demonstrated some of the methods of utilizing the printing technologies, such as inkjet or dice or screen printing of various active materials, such as here you can see the dice can be nicely printed, and also like the electrolyte can be printed, and even the catalyst materials can also be printed, as I showed you. So why is it important? This is one of the examples for perovskite ink that was also we have demonstrated in one of our studies through inkjet. And why the printing like I prefer is because it improves the reliable process control. That is extremely important in any nanotechnology based kind of technology development, because if you make a batch of solar cells and if you use some kind of manual method or like semi-manual method, so it affects the reproducibility of the performance, and that is not acceptable to the customers, and also like in the initial testing phase or the development phase. So printing allows like the reproducibility and reliability in a complete product design. So some of the commercial products are already available and have been proposed recently. So these are some of the success stories by some of European and Japanese companies. So this is Exeger, a Swedish company. They have also received very good funding recently. And now you can, I believe that they are now selling this headset that it does not have any battery, and then under very low lux light intensity conditions, it is said that it can work very well. And also, yeah, so you can go through links, and then there are also some other companies which are proposing some other solutions for these kind of portable devices. So it is possible, like, to utilize this technology for indoors and under mild conditions. So the conclusion is that, of course, like dye-sensitized solar cell is a scalable PV technology, and then can be fabricated with a variety of configurations. But nevertheless, there are some challenges in order to achieve, like, high conversion efficiencies at module level. So there are some stability issues, but it seems that it is suitable for indoor applications. So some of the achievements I would like to highlight. So this was funded at Alto, but after that I got an opportunity to move to a new place where this project is started now, and it's going good. And then these are some of the highlights of my research work that has been presented in different exhibitions. And also some videos surfaced. I have provided the link, so any young scholars can go in order to get some motivation. And there is also like one brief clip appeared from the University of Oulu. These are the doctoral researchers that are hired on that project which is started. So we are all working on both kind of technologies, the dye-sensitized solar cells and also the perovskite solar cell. And these are some of the recent outcomes after my joining. So you can all go through and give me a feedback about it. And also I have been developing another this perovskite based solar cell technology that is actually derived from dye-sensitized solar cells. And through different fundings, like I with my other colleagues, I was able to scale up on very large scale size, let's say 40 by 40 square centimeter. So all these achievements are a great motivation for not for myself, but also some of my partners as well. And with that, I'm extremely grateful to all of my collaborators and all of my friends and colleagues who helped me in achieving these kind of milestone. And I'm also equally grateful to all of my financiers. So as I mean, with that, like we have raised almost 2 million euros funding, and trying to hunt some more in order to realize a factory to produce these kind of modules. And I'm also thankful to all these companies who are helping me in establishing my labs. And with that, I end my presentation. I'm open up for the questions. Thank you so much.
If you have any questions. Okay, afterwards. Thank you so much, sir. Thank you so much. I request Engineer Sohail Bashir, Chairman, IEP Karachi Network, again to come and address the audience, please.
Thank you. Actually, I already gave my part, but few of our friends have just joined, so I'll take this opportunity to welcome Dr. Javed Yunusupal, President, Institute of Engineers, Pakistan. Engineer Hafiz Mohammad Ehsanul Haq Qazi, Chairman IEP Islam, Rawalpindi and Islamabad Center. Engineer M. Murtaza Khurshid Saab, Chairman IEP Multan Center. Engineer Mohammad Afzal Guraya Saab, Secretary IP, Lahore Center. Engineer Group Captain M. Najmuddin Saab, Secretary IP, Islamabad Center. Engineer Suhail Ahmed Khwaja Saab, Secretary IP, Multan Center. And of course, just now, the Vice Chancellor of the NED University of Engineering Technology, Dr. Sarosh Hashmat Lodi, the Pro-Vice Chancellor, NED University, Dr. Tufail, has also joined us. So, and the Dean of the Architecture and the Registrar, NED University, have also joined. So I take this opportunity to welcome all of you to this 7th International Electrical Engineering Conference. As already I told before the audience that this is the 7th International Electrical Engineering Conference. We started this journey in 2016, and since then we are continuously holding this, and we are proud that in this venture we have the partnership of all the Pakistan Engineering Council accredited institutions of Karachi and Sindh. So it's a very good teamwork that we come out with very good papers. And as I was giving a briefing early morning in the Central Council meeting, that around 92 papers came and 32 were accepted for the oral presentations, and then there are poster presentations, and the list is before you. You can see that lot of very good papers have come, and you will definitely, tomorrow will be the whole day. There will be 6 technical sessions all and parallel. So in parallel and at 3 different locations. So you will have many good papers to witness and to listen. With these, I'll request the President IP, President of the Institute of Engineers Pakistan, Dr. Javed Yunus Uppal, to please come forward and say a few words on this occasion. And I'll also request later the chairman of the Islamabad Center and the chairman of the Multan Center present here to say a few words on this occasion. Thank you. Dr. Javed Yunus.
Ladies and gentlemen, Assalamu alaikum. जवाब तो दे दिया करे. I'm very happy that I am here with you in Karachi. Normally I am in Lahore, and Lahore happens to be the headquarters of the Institution of Engineers Pakistan. Now I can see a lot of young people around, and some of us, the older lot. And in a few minutes, I want to express what I am trying to say. I have recently been to China, and then I went to United States, and I have spent some time there. And we are on a verge or a doorstep of a 4th industrial revolution. The whole world is going to change. It has already changed to some extent. And this is where in China, actually, they have established an international collaboration for the 4th industrial revolution. And Pakistan, they have taken us as a founder member of that collaboration, that international collaboration. So this is a mark of pride for Pakistan. Now, what is this 4th industrial revolution all about? In fact, all 3 revolutions earlier that took place, they were in Europe, basically. Europe saw the first industrial revolution, then the second one, then the third one. But in Pakistan, a country like Pakistan, they all were mixed up. So all revolutions came just mixed up in a kind of a mixed up fashion. So this 4th industrial revolution, in fact, is an onslaught of smart technologies and smart systems. Now, as you see, we were listening to a researcher in Finland. The researcher is in Finland, and we are receiving his words in Karachi. So this is a part of the smart system that we are enjoying today. The distances have really been smashed. So people who are sitting here, they have an approach, an outreach to almost all parts of the world. So this is the first step. Then smart technologies today, in fact, mechanical engineers and electronics engineers, they know what I'm trying to say, because it is the word of IT and IoT, Internet of Things. Word of IT and IoT has made us able to see, to observe phenomena which we had never been able to watch or see or utilize. So another important aspect that's going to come is that previously it was the capital who dictated. People who had the capital, they were the dictators, and people who were doing research and studies and innovations, they had to search for the capital, search for the funding. Now this is going to be reversed. You will be surprised, but this is going to be reversed. Now, the smart systems and smart technologies, researchers, laboratories all over the world, they are becoming one collective entity, and the capital is going to rush towards them. It's this new system, a system where knowledge is power. We don't feel that knowledge is power today, but this is going to come. And some of us who are studying and who are doing researches like solar cells, we were just watching, they have an opportunity. They have to come in a real sense in innovations. They have to do innovations, and innovations, all we know, take place at very small level, in laboratories, in universities, in research institutions. And I think I can see a big hope for them, because if you have an innovative idea, capital is going to rush towards you. And this is a new hope for the new world. And this is going to come through this fourth industrial revolution. And China has taken an initiative, and Pakistan has become a co-founder of it. And now we have a direct link to participate into this fourth industrial revolution. So see what is really required in Pakistan. How can we serve the people of Pakistan? What are the needs of our people? So we need to be people-oriented. Our innovations and our researches have to be people-oriented. Look after the welfare of the people as a whole. Then 60–70% of our population living below the poverty line. I think we need to focus at them today, and all our innovations and researches guided and in collaboration with these international organizations should be focused towards the welfare of the impoverished people of Pakistan, at least Pakistan today. So this is what I try to convey to you. In Lahore, you are welcome to come in Lahore. In Lahore, we have established an innovation cum incubation center. In Institution of Engineers, Pakistan, we have established a center. We call them Innovation Incubation Centers, where we will encourage young engineers, electrical engineers, mechanical engineers, other specialties to come up with innovative ideas. And those innovative ideas should really direct towards the people at large, our people at large, who need very simple ways of earning for themselves. So I think this is a new area, and we have to work for it. So thank you very much.
Thank you, sir, for your enlightening words. I'll request the chairman, Islamabad Center, to please come and say a few words on this occasion. Thank you. Engineer Hassan Qazi.
Bismillah ar-Rahman ar-Rahim. I was not knowing that I had to address with such learned people at the NED University. My previous visit to NED University, as I remember, was early 80s when I was in the University of Engineering and Technology, Lahore, Texla campus. We came here on a study trip, and after that, this is another historical day that we are here in front of you. And I have also honored to be contemporary timing graduation when your Vice Chancellor, Dr. Hashmat Lodi, he was also Sarosh Lodi Sahab, did his graduation from NED, and we did it from the Lahore, UT Lahore. But when I came this time, I was wondered that he has done a lot to improve this university and the research going on, that these things are demonstrated by your activities, by your conferences, by international conferences. During COVID time, you were able to manage such good conferences and such good articles. I pray for your success, and inshallah, hopefully you will be doing the same in future. Thank you very much.
Thank you, Qazi sir. Yesterday, Dr. Sarosh was sharing with me that one of your school classmates was his buddy in project partner at NED, Jamil, and we used to say him as Jamil Fata. So, and now he's in New York. So what a day. Now I'll request the chairman of the Multan Center to please say a few words on this occasion.
Assalamu alaikum. I am basically a civil engineer, and I served for Government of Punjab in irrigation and power department, and retired from the post of chief engineer there at Multan. I am very happy we were here today in the morning for our own Central Council meeting of IEP, and it is honor for me to see such a progress in the researches and such type of conferences with the help of IEP. This is the function of IEP.
Really grateful. Thank you so much.
We should appreciate it. And thanks a lot.
Thank you, sir. Now it's my proud privilege to request the Vice Chancellor of the NED University of Engineering and Technology, Dr. Sarosh Hashmat Lodi, to please come forward and say a few words on this occasion. Professor Dr. Sarosh Hashmat Lodi.
Bismillah ar-Rahman ar-Rahim. Respected Dr. Uppal, my dear friend Hafiz Saab, my colleagues from all over the country, members of the Institution of Engineers, dear faculty members, the Pro Vice Chancellor, Dr. Mohammad Tufail, Asim Hussain Saab, Registrar Saab, the two respective deans, Dr. Noman and Dr. Saad Ahmed Qazi, the Chairman Electrical Engineering, Dr. Atullah Khwaja, my colleagues, Assalamu alaikum. Today is a very sad day in the history of this institution. We have lost a wonderful friend, an academician, a wonderful researcher, and a dedicated individual. It was an untimely death. He died very young. And he was not keeping well for the last several months, and his health was deteriorating. But accepting death is always very painful. And I pray that Allah Ta'ala gives him the highest place in Jannah and give a lot of sabr to his family. His children are still very young. And it will be very difficult to find a replacement. It's very, very difficult to find such a wonderful man. And despite of the heavy heart and the burden that we are carrying, we decided to continue with this event. These kind of events are very important for us as university and for IEP, obviously, as a professional institution. It's a wonderful understanding that has developed several years ago of collaboration between NED and IEP, which eventually has involved other institutions and universities in the city of Karachi, and then it has further extended to the entire province. And then it has further extended to Balochistan also. So you see, it's very, very important to have events like this, to share ideas, to share knowledge, and above all, develop collaborations. Allah Ta'ala has made mankind in such a manner that we can't live in isolation. Even though this wonderful magic is making sure that we start living in isolation, but still men need company. They need to talk to somebody. They need to collaborate. And the more the merrier is the concept. And I truly believe in that. And it is indeed my privilege and pleasure that we are having this 7th International Electrical Engineering Conference. And we had a mechanical engineering conference earlier on. And then in the month of June, we'll have a civil engineering conference also. And it is heartening to see the collaboration and the bonding that is taking place with the professional institutions. And I would encourage the other centers to follow the same path. It's getting things on a bigger scale is much easier when academic institutions are involved. And I was so happy to see the number of papers that we have received. 90 some papers, 92 to be very exact. And in a conference, it's receiving 90 some papers is not an easy job. So I must praise the organizing committee for reaching out to so many people. And then obviously we have to only select a few. So the success rate was about 30% or 33%. Only 30 some papers were selected for presentation, which once again is Sharif Saab, I'm not done yet. Thank you. You know, as a Vice Chancellor, you're supposed to listen to me. And you have to say, yes, sir. That's the kind of mindset that I'm into these days. I'm terribly sorry, but I'm not that kind of a person, but I want everybody's attention. You know, so the most important thing is to get, the contacts. I have seen these contacts into professional, turning into professional relationships, turning into research collaborations, and at times turning into personal relationship when the marriages takes place between, friends. At the end of the day, we make friends. So there's a huge opportunity. And so Bashir Saab, if you allow me, I would like to congratulate you for keeping us busy, least to say. And I also would like to thank the President, Institution of Engineers, who has made an announcement today at the Central Council meeting that in the ASAC, the Asian Civil Engineering Coordinating Council, IEP Karachi chapter will be nominated for award. So that's, thank you very much for this wonderful event. Even though, there are chairman of Karachi, Islamabad, Multan, and the president himself is available, but I'm still missing Amir Zamir Khan. No event is complete without him. So, so convey my regards to him. And I hope that we'll have a wonderful day tomorrow also. Thank you very much.
Thank you so much, sir. Ladies and gentlemen, it's my proud privilege to introduce our chief guest and keynote speaker, Dr. Naveed Sherwani, Chairman and CEO, Global Semiconductor Group. He's world-renowned chip expert, researcher, author of several books, serial entrepreneur, and academician. He has done most of the work as a serial entrepreneur, and his history is about forming and building companies. He is also an NEDian. Now, I would like to request Dr. Naveed Sherwani to address the audience online. Sir, please.
Dr. Sarosh Lodi Saab, Sohail Bashir Bhai, Dr. Saad, professors, students, Assalamu alaikum. First of all, I really want to thank the organizers and Dr. Saad in particular to giving me this honor and privilege to have this time to address all of you guys. And I think this is a very important subject. And the subject that I want to really talk about is what has happened in the last few years, how semiconductor, which was important to the world, but now suddenly what has happened is that semiconductors have now become completely different in importance in the world economy, in the world politics, in sovereignty of nations. So semiconductor has taken a completely different form and shape. And it is my opinion, just like sugar in the past, and before that coffee, and then in between slaves, and in the recent decades, oil was a commodity that shaped the world. It is my opinion and opinion of many experts around the world that semiconductor is the commodity that is going to shape the world in the next 50, 60 years. So why is that? So I think I thought it's important that we talk about that. And more importantly, I think we should talk about why is that a historic opportunity for Pakistan, and why it is even more importantly an opportunity for 20 plus universities, heads of which are attending here from Karachi and other parts of Pakistan. Why it is an amazing opportunity for all of us to do something. Such opportunities come, in my opinion, once in a lifetime. And we are observing that opportunity right now. And I think it's important that we understand this opportunity. This train will leave the station, other people will fill, and then we will be left behind. So I think it is important that we should understand this at the level of students. We should understand that at level of professors, researchers, entrepreneurs, policymakers, government officials. Only then I think we will be able to take advantage of this opportunity that in front of us. So let me tell you what I see that as an opportunity and then role that Pakistan can play. So if you look at semiconductors today, today it's around a $600 billion industry. And it is projected that in about 3 years or 4 years, we will cross $1 trillion. And in terms of imports, for example, if you look at China, China is about half of the semiconductor business in the world, projected to be. So if the world is going to be $1 trillion industry in about 3 to 4 years, China will be about 500 billion of that. Today, China imports $250 billion worth of semiconductors from all over the world, which is far more than what they import anything else, far more than oil that they import into China. So in other words, for China, the number one import is semiconductors. Secondly, if you look at any aspect of our life today, any, be it education, be it communication, be it banking, be it health, be it defense of a country, be any aspect of industry, any aspect of economy, any aspect of entertainment, any aspect that you can think of, you cannot potentially name one thing that we can do today without a very important contribution of semiconductor. In fact, they're just simply not possible without semiconductor. By semiconductor, I mean semiconductor and semiconductor related things, which you have hardware, and then of course you have software sitting on top of that. But obviously you need hardware, and hardware has some roots somewhere in the whole entire semiconductor chain. So if you look at any aspect of our life, semiconductors are playing a very important role. And many people who tell me that, oh, we have become independent in this and independent in that, I always remind them that that is actually not true. For example, all of you know that Pakistan makes JF-17s. We make parts of other aircrafts as well. We assemble them in Pakistan. But in fact, the entire navigation system and many other systems of those aircraft are based on certain FPGAs that actually Pakistan imports. So if import of those FPGAs and certain other chips is somehow banned and Pakistan could not import, yet if you can make each and every part of that sophisticated aircraft, you will not be able to make a JF-17. This is also true for cars. It is also true for missiles. It is true for tanks. It is true for all kind of machinery, everything. So this is, first of all, we have to understand that our existence as a nation, people, how we operate, how we, various different things the economy does, it all depends on semiconductors. That's number one. Number two, with the advent of 5G and artificial intelligence, the importance of semiconductor is about to change significantly. Why is that? As the 5G rolls out, 5G will enable us to completely connect all elements of our economy, all elements of our being onto the cloud. Once we cloud that, it would be possible to create digital twins of all the industries. That will allow us to create an integrated supply chain. And if you could do that even within industry or across the industries, you can get huge efficiencies because of that. Now, add on top of that AI. AI allows you to add intelligence in the edge. And if you are able to do that, you will be able to do many intelligent actions on the edge, where with the machines, with the robots, with the entire supply chain, with the various elements of your economy, that you can make your economy much, much more efficient than it was before. And because of that, the semiconductor role in our economy is going to become much more than it is today. This is a reason why the world has now got itself into a trade war. So if you see the beginning of the trade war between China and US, that trade war actually started with a speech given by President Xi in 2015, in which President Xi said that by 2030, we will make 75% of all semiconductors that we need in China in China. At that time, China was making around 5-7%. Today, China is making around 15% of what they need. So 85% of semiconductors that China needs actually come from outside. They are made mostly by European, Korean, South Korean, and American companies. And so they import 85% of semiconductors. Of course, they make parts and systems, and they export them out. And why is that? Is because that two nations could clearly see that there is that the role of semiconductor, role of 5G, role of AI is going to determine which nation is going to lead the world in many aspects. So as soon as the trade war started, China realized that their self-reliance plan, which they should have done much, much earlier, is going to determine the future of their country, and they redoubled. So as the China redoubled its effort, US started putting more and more sanctions. So actually what has happened now, that everybody around the world has realized that semiconductor is something very crucial for them. They must somehow have independence of semiconductor. They cannot depend on some other nation providing them semiconductor. Now, semiconductor is not a very simple thing. It's a very complicated supply chain. If you think from materials that we use are very exotic. We use cobalt, nickel, zirconium, all kinds of material in manufacturing. Then we have very complicated manufacturing processes depending on 5 nanometer, 3 nanometer, going to 1 nanometer process, which cost $20–30 billion. Then we have packaging issues, again, very expensive, capital intensive. Then we have design, IP development, and that is a very human intensive process. And those people have to be very well trained. So how can nations go about and do this? So if you think about the world, it is now getting broken up into different parts. US has decided that we will become independent. China has decided they want to become independent. Europe has decided they want to become independent. Korea is putting in their efforts. India has decided to put in their efforts. If you look at these things, what is happening is that all of them are committing hundreds of billions of dollars to semiconductor industry. I can tell you that, 5 years ago, no such money was being pouring into semiconductors. Now more money is pouring into semiconductor than actually even anything else in the world. So semiconductor industry is the #1 industry in the world in terms of the total dollars being poured into it. Companies like Intel are not undertaking projects worth $90 billion in Europe. Intel has committed to spend $90 billion. China has started a fund which is worth $300 billion plus another $100 billion from the private investors to invest in China. That's $400 billion. If you look at CPEC is a $60 billion project between China and Pakistan, between two nations. That is in the history of Pakistan, the most important project, and that's worth $60 billion over several years. Now imagine China itself is spending on one industry $400 billion. Europe has CHIPS Act, they're spending a lot of money. US is spending about $100 billion, so on and so forth. So you can imagine anywhere between $700 to $800 billion of money is being poured into semiconductors. To do what? Everybody wants to make their own chips, which means if one chip, one system was good enough for the whole world, now the same chip will be made by many different people. Give you an example. 7 years ago, 10 years ago, we had only one GPS system. Everybody used it. It's the American GPS system. But multiple wars that happened in Gulf and other places, it became clear to people that if we depend this GPS system, if we have a disagreement with the owner of the GPS system, they will shut off the GPS system and nothing will work in our economy. So this is something we don't want to do. So Chinese started their own GPS system. Japan started its own GPS system. Europe started its own GPS system. So now we have multiple GPS systems. In fact, Pakistan has already moved to the Chinese GPS system. What does it mean? Previously, there was one set of chips that you could use for tracking the satellites and doing all the various other navigational tasks we're doing. Now we need to have several sets of different chips for the navigation because there are different GPS systems. They have different encoding systems. They have different algorithms and protocols. So in other words, previously, if you could make one chip, now you have to make 5 chips for the same thing. Now think about the same thing for your networking. Nobody trusts anybody else networking. You have to do the same thing for communication. You have to do the same thing for everything. What does it mean? It means that the demand of chips, let's say world was designing 7,000 chips a year or 10,000 chips a year. Now the world will have to design something 35, 40,000 chips a year. And then we have to first figure out how to manufacture them. Then we have to figure out, package them and test them and do all of those things. But if you just look at the world deciding to design all these chips, one point will present itself to you. Where are we going to get all these people who are going to design these chips? Right? I'm just talking about the design part. Forget about the manufacturing part. Manufacturing part not only has the issue of people, has also an issue of capex, and then a lot of other things. And as I said, 700, actually $800 billion are being spent in setting up those factories. Let's assume they can set up the factories, which is a very complicated and difficult thing. Let's assume they can get the materials, which is also a very complicated thing. But at the end of the day, you will find out that it will come down to a shortage of talent, people. So just in the design, we estimate that anywhere between 1 to 1.5 million people are required in the next 3 years globally. And how it is distributed? The distribution is approximately 350 to 500,000 people in China, approximately 100,000 in India, another 100,000 in US, and then the smattering is in Malaysia, Korea, Japan, other places. China does not have 350,000 people, 500,000 people. India is struggling with having another 100,000 trained people to do that. I can tell you that in our companies in India, the attrition rate, the people who are leaving jobs, is in the range of 25%. So in other words, if you have 1,000 people in your company, 250 would leave you this year and they will join somebody else. How many companies can survive this kind of iteration rate? Secondly, the salaries are going up at a phenomenal rate. In China, in my company, I have 5 companies in China. I believe we have not been able to hire, in one of my companies, Rapid Silicon, we have not been able to hire a single engineer in the last 6 to 9 months. They're not to be found. There are so many. In China, we believe there are something like 30,000 companies have been established or are being established in various different parts of semiconductor. So China would need 350 to 500,000 people. How will they get these people? How will US get those people? How will this, I think, is a historic opportunity for Pakistan. The global shortage of people, not just little bit shortage. We are talking about humongous amount of shortage. So I think, and many other people agree with me, that this is a historic chance for Pakistan to join the semiconductor revolution, this great issue that is going around all over the world. And not just because of the economic reason, because we can get some people in Pakistan jobs and that would be very important for our economy. But I believe it is also important for the sovereignty of the nation. I think a day will come that nobody will give us some chips and we will have to align with ourselves with somebody who will give us chips. Otherwise, what will happen to you is that everybody will blockade you. You will not have critical supplies of whatever things that you need to run your economy. And semiconductor is once something on which it is very easy to choke somebody else, just like China is being choked right now. In China, there are 250 companies which are on our entity list. They cannot import things from around the world and things are going on. So I think it is not just an issue of economy and opportunity, is also an issue of sovereignty, not just for Pakistan. It's a sovereignty issue for US. It's a sovereignty issue for India. It's a sovereignty issue for China. It's a sovereignty issue for Egypt. It's a sovereignty issue for Brazil. So it is a sovereignty issue for every nation around the world. If you want to stay independent, you have to be independent in critical aspects of your society, and semiconductor is going to be one such very crucial element. So what role can Pakistan play? I believe China, in particular, let's look at the China opportunity. China needs, in the next 3 years, 350 to 500,000 people to prop up its semiconductor industry. Where will these people come from? So people say, come on, Naveed, China is 1.4 billion people. Why can't they just, train 500,000 people? Actually, they can't. And the reason is as follows. China not just has need in semiconductors, they also have a need in software. They have a need in manufacturing. They have a need in robotics. They have a need in many, many other things. So the total output that is coming out of the hundreds of universities in China, actually thousands of universities in China, is being spread into all those. China's economy is growing on all aspects. So this is the reason why China thinks that they can produce probably 100,000 over the next 3 years, but they cannot meet the rest of the needs. So where the remaining 350, 400,000 people come from? It cannot come from India. It cannot come from US. There is no other large nation which can supply that. So it has to be friendly nations, which are friendly to China, who can provide this. So I believe, this is my opinion, that 100,000 such people can come from Pakistan. If we have 100,000 trained electrical engineers or computer scientists, which we can quickly train in microelectronics, some aspect of design, be it verification, layout, physical design, IP development, any aspect, we can provide jobs for 100,000 people. This number looks big, but for a nation, it is not a big number. And if we could actually do that, we have numbers to show that it can bring around $3 to $4 billion to Pakistan every year, in addition to everything else that it can add to the economy. So how can we go about do that? So I think among these 100,000 people, we think two ways they will be employed. One, Chinese companies will come to Pakistan and open their design centers. We have had numerous discussions at company level and even at government level. On a recent trip of our Prime Minister to China, we had numerous discussions with the Chinese government at the government to government level. What can be done to facilitate for Chinese companies to come and establish their design centers? The government of Pakistan has put together an incentive package. This package says, okay, if you come here, we'll give you these facilities, we'll give you land, we will give you tax incentives for 10 years, tax holidays, we'll give you many. There's a whole incentive package that has been put under the CPAC, and then under the CPAC collaboration with STZA, a whole package has been put together for the Chinese companies to come and open their design center. Then we are in discussion with many Chinese companies who want to come here and start their design centers. But the first basic thing they ask for is, do you have the trained manpower that we can employ to start our design centers? So that has led us to band together all the universities, all the researchers, the companies, and put together a plan which we call Pakistan National Semiconductor Plan, PNSP. And that plan basically says, let us get the universities, let's establish some training centers, let's get all the companies together. How can we start a training program so that we can have these engineers trained as quickly as possible? We think taking a good student from a university in Pakistan, we have looked at about 42 universities, including the 20 universities which are present today here. And we have looked at the output, we have looked at the gaps of those students in the knowledge. We have tested several thousand of them already. We have trained around 500-600 of them to know exactly where the gaps are. We think it will take about a 10-month program, 3 months to cover their gap, 3 months to train them in a tape out of an actual chip, 3 months for a job specific training, and then some soft skills and other things so that we can prepare them. In line with that, we have also prepared a plan to start 4 ATIs, Advanced Training Institutes, one in Karachi, one in Lahore, one in Islamabad, one in Peshawar. Inshallah, the first ones will start right after Ramadan in Lahore and in Karachi first, then in Islamabad, then in Peshawar. And the purpose of those training institutes would be to take the output from universities like NAD and other esteemed universities in Karachi, give them this training. But what will be different about this training institute is we will not admit a student in our training institutes unless we guarantee a job. In other words, we will give a job offer to a student as he or she enters the training institute. But this training institute is just a start. So first of all, we are in the first batch, we will take about 100 people, 125 in Karachi in particular. And we'll start with that batch. And right after that, as soon as we get experience, we will scale it up. We need to scale up these training centers so that they can go to a capacity of about 1,000 and then 2,000 within a year, so that we can get to a number of 10,000 people that we can train in Pakistan over the next 3-4 years. So this will meet the need of the Chinese companies and US companies who are coming into Pakistan and employ those engineers. I believe today in Pakistan, and I think I recall having a discussion with Sohail Bhai, that I think we have something like maybe 15,000 electrical engineers in Pakistan, which are either unemployed or underemployed. Maybe I'm misquoting the number, but there is a number which is fairly big, that there is an existing pool of engineers, electrical engineers, and there may be additional computer science people as well, which are available for training as well. So I think there is enough pool that we can start with and we can train. This is one aspect. Second aspect is the people that can go from Pakistan to China. Currently, China requires people to have a 2 years experience before they can get a visa. We have requested Chinese government to actually change that visa requirement, and because they need the people. And if we can give them this kind of a training, that they consider that training to be equivalent, because the training will be very specific, to be equivalent to 2 years of work experience, and then admit those people into China so that Pakistanis can go. We've also requested, as part of the visit of the Prime Minister to China, that we change the visa requirement for the students, which are thousands of Pakistanis which are studying in China, so that they can continue after studying to work in Chinese companies. All those things hopefully will lead to our goal of 100,000 Pakistanis either working in Pakistan or in China, or to work in this microelectronics and semiconductor industry. We also think that we have a similar kind of a headcount shortage in US. It's very difficult to hire people in US. So we have also asked for actually a consulate to be started in Silicon Valley, so that we can increase the connection between Pakistan and the government of Pakistan has already granted that. And as a result, inshallah, very soon, a consulate of Pakistan will start in Silicon Valley, so that we can have a consulate officers which can start talking to silicon companies in Silicon Valley. How can we facilitate setting up of design centers in Pakistan? We have already talked to many different companies in Silicon Valley. They have said, if you have trained people today, we are willing to open a design center in Pakistan. In fact, the total capacity we are training in our ATI right now is about 400. I've talked to 5 companies. They've already committed 400 engineers. They're saying, if you have 400 engineers trained, we can start tomorrow. So we will have those job offers, inshallah, right after Ramadan. When we start our ATIs, we will be able to give those job offers to our students, and then train them and get these training centers in Pakistan. I think this brings me to my last subject, role the audience sitting in front of me can play today. You are the elite universities of Pakistan. You have elite programs. You are already teaching microelectronics. You are already teaching computer architecture. You are already teaching various different aspects of electrical engineering, which can be tuned. It is our belief that no matter how many training institutes we start, the dream that we have of Pakistan playing a very big role in this semiconductor revolution that is happening can never be done by any training institutes, because training institutes can never solve the problem that universities can, that capacity. You only can solve the problem. So we would like to work with all the universities to upgrade their programs, look at the gaps they have, strengthen their curriculums, provide soft skills that are needed to work in a real environment, include tape-out programs in their curriculum so the students have real experience of experiencing a tape-out, how exactly a chip is designed. And they don't have to become a part of standard curriculum. These can be additional classes. We understand HEC and PEC has requirements that take time, and naturally we agree with that. We don't think that HEC and PEC should change their requirements overnight just because Naveed Sherwani says that there are some chips to be designed and there is a global opportunity of 100,000 people that can be employed in Pakistan. I agree with that. But given the constraints of HEC and PC, we can do a lot of things. We can enhance our programs. We can set up labs inside the universities where we can provide this training. And I think this is what we would like to do. We also would like to ensure that universities know what these gaps are. We will share it with them based on the research that we have done. Many folks from NED are already involved. Dr. Saad, Dr. Fahim, from UIT, Dr. Ali and others, from DHA Sofa University, Sir Syed University, other universities, PF Kites. These are people are already participating in this discussion in Pakistan National Semiconductor Plan. But we should have all this information available and we should all participate. And this is a role that all of you can play in preparing these students. And our job at the entrepreneur level, our job at the governmental level, our job at policy level would be to encourage the companies from China and US. But that is our first step. Inshallah, what we hope that after all these companies come and start, then many of those entrepreneurs will start their own companies and will start designing these chips in Pakistan. Maybe simple ones first, that we would need microcontrollers and things like that. But eventually you grow up and you make more and complicated chips over time. It's a process that may take 10, 15, 20 years, but it's always important to take the first step. So I believe that this is a historic opportunity for Pakistan to get onto the bandwagon of semiconductors. Huge shortage that exists of the talent around the world. We have the population, we have the universities, we can train these people. We have amazing relationship with China. We have amazing relationship with US. People from US are willing to start the design centers. China folks, and I think if you look at that, and by the way, it doesn't limit there. We have around 3,000 students in South Korea right now. We are studying, and they will be most likely employed in Korean companies. Many of them are doing masters and PhD there. So opportunity exists there as well. And Middle Eastern countries, Saudi Arabia has just announced a $1 billion fab that they're putting up, and they want to start many design centers. Pakistanis can go work there. Oman has just asked us to put up a program there. Abu Dhabi has asked. I am going to Egypt next week. Egypt wants, all of them will need engineers as well. So it is a historic opportunity for Pakistan. You guys have the golden key in your hand. If you guys decide to work together, we all work together, upgrade our programs, create the highest quality engineers that can participate, be trained as chip design engineers. There are many different aspects of chip design they can be. I think Pakistan should not miss this opportunity. I think this can bring great prosperity to Pakistan. I think it can bring jobs to 100,000 engineers. I think it can also bring great economic opportunity for Pakistan. And we can, bring $3 to $4 billion into Pakistan economy, which is a very big number for Pakistan actually. So with that, let me finish. But I think we should reflect on that. And if any of you would need any information, Dr. Saad, Dr. Fahim, Dr. Ali are in the audience today. I think they'll be more than happy to provide you that information. Anybody who would like to reach out to me, participate, do anything about this, will love to help out. But I think you guys have a very important role to play. And I want to make sure we should not miss this opportunity. These kind of opportunities only come once in a lifetime. If we don't actually do that, other nations will step up. Bangladesh will step up. Indonesia will step up. Kazakhstan will step up. Uzbekistan will step up. They have people, they have universities, they can train the people as well. But Pakistan would have missed that opportunity. I hope, inshallah, working together, we will not miss this opportunity. I can tell you one last thing. In year 2000, Y2K had not just happened. India had no export, very little export of software. Everybody knew about Y2K. Nobody took up that opportunity. India did. Today, India has total export of $160 billion of software, which is more than the export of Saudi Arabia of the total oil that Saudi Arabia exports. Just that one thing that India does in software, they export $160 billion of software today. It started in year 2000 because India saw the train leaving on Y2K and they adopted it. They made it a mantra, and today India has this opportunity. Pakistan can have $100 billion opportunity 20 years from now if we decide to invest the time, money, effort. But more importantly, we should have the vision that we want to do that. Thank you very much. Assalamu alaikum.
Thank you, Naveed, for your wonderful talk. When you were saying Sohail Bhai, I was feeling frightened because Naveed is my classmate at the NED University. So we were good friends at that time. I think this is the good time if Dr. Sarosh could respond for the various things that are going on in this area, especially what Naveed referred to. So, Sarosh, although it was not on the agenda, but I think it's a good time to respond.
You know, I love speaking on mics. And when Naveed said Sohail Bhai, I felt so good. Now I can say Hafiz Bhai. Now, thank you very much, Naveed. It was a wonderful thing that you are doing. And as all of you know, that the ATI in Karachi is sort of established already at NED University. Dr. Saad Qazi, Dr. Fahim, Dr. Ali Ismail, Dr. Hashim, they are working very closely with Dr. Naveed Sherwani to develop the curriculum. We have already started, planning to take a first cohort of the engineers who will be trained into semiconductor designs. And the test, I reckon, is on the 22nd of August. 22nd of August, there will be a test conducted for anybody who's interested in their training. Obviously, there will be prerequisites and there will be a very stiff selection. But that training will start from September, 15th of September, inshallah. So, Naveed, thank you very much for trusting in us. And I'm sure that with the kind of vision and the leadership that you have, mashallah, you will find us right behind you to support this national cause. I assure you. Thank you very much for agreeing to establish the ATI at NED University. Assalamu alaikum.
My pleasure.
Thank you, sir. Now, I would like to request Engineer Asim Murtaza Khan, President, NED International Alumni Network Association, Pakistan, to come and address the audience. Thank you, sir.
Bismillah ar-Rahman ar-Rahim. Distinguished guests, Mr. Naveed Sherwani, Sir Javed Yunus Uppal Sahab, Sohail Bashir Sahab, Sarosh Azmat Lodi Sahab, Tufail Sahab, distinguished Saad Qazi Sahab, because this is your conference today, and all the participants, ladies and gentlemen, Assalamu alaikum. I'm really honored on behalf of the NED, that's the NED International Alumni Network Association, to be associated with this conference. It's an honor for the association. Why are we associated? It's very simple. We have this logo here, 100 years, centenary year for NED University, and the NED, the association, is really leading the way to celebrate this centenary. It's not NED, it's for the country. I keep emphasizing this, that NED has completed 100 years. We are celebrating it. We started this in 2019, December. This year it's going to be a big event, but it's a national event. Uppal Sahab, you in today's Central Council meeting, and we heard you today. You have always propagated the national cause in Pakistan and internationally. That's our agenda also. NEDN, we are spread out all over the world. IEP and the NEDN, we are hand in hand because we have a common cause. And we hope to really progress it. It's our charter. We are very encouraged by your kind words and your vision to progress it. And we look forward to all the support of IEP, not IEP Karachi Center, but the IEP Pakistan as a whole to progress this cause. Thank you very much.
Thank you, sir. The Secretary of IEP Islamabad Center especially requested me that he would like to say few words, 2 to 3 minutes, especially on the semiconductors. So I'd like to give him an opportunity to please come forward and say a few words on this.
Thank you very much, Suhail sir. Actually, I was listening to Engineer Naveed. I am a retired Pakistani Air Force officer, and I worked on sophisticated state-of-the-art electrical electronic equipment. So Naveed Bhai was mentioning to create a pool of engineers who will be available to work on the semiconductors. I recall back in 1976, it was my first job in the carrier telephone industries, Islamabad. And they used to manufacture these chips. Unfortunately, over a period of time, in the successive governments, that factory, like many other industrial units, collapsed. So now we are only left to the universities, the laboratories of the universities, and the forces where we have such laboratories. So I'll request the team which is made, they must consider that we should be having those training institutions from where we produce engineers who can actually deliver. Because I recall, since I have served in Pakistan Embassy in Germany as technical attaché, and there was a requirement of computer engineers, programmers, and so many things. Germans gave us 10,000 vacancies. And once we put the requirement in Pakistan, they gave us 500, and those were computer literates. They were not even computer programmers, what to talk of computer engineers. So we missed on that account, and Indians gave them 20,000 engineers. So we have very good universities, and it is one of those LUMS Institute of Electrical Engineering, similarly UET Lahore and some other universities. And we should coordinate the effort with services, Pakistan Army, Pakistan Air Force, Navy, and strategic organizations. That is the place from where we can generate a good team of engineers. Thank you very much. I told you 2 to 3 minutes, it is now over.
Thank you, sir. Ladies and gentlemen, it's time for the distribution of mementos. I would like to call upon stage Engineer Professor Dr. Sarosh Hashmat Lodi, Vice Chancellor, NAD University of Engineering and Technology. Engineer Suhail Bashir, Chairman IEP Karachi Center. Engineer Professor Dr. Saad Ahmad Qazi, Dean Electrical and Computer Engineering, NAD University, and Convener IEEC 2022. Engineer Professor Dr. Ataullah Khwaja, Chairman Department of Electrical Engineering, NAD University, and co-convener IEEC 2022, for the presentation of awards and mementos. I would request Pro Vice Chancellor Dr. Mohammad Tufail to please come on stage. Now, I would like to request Engineer Dr. Javed Yunus Uppal, President IEP Karachi Center, to please come and receive his memento from Vice Chancellor NED University, Engineer Professor Dr. Sarosh Hashmat Lodi. Now, I request Engineer Hafiz Muhammad Ehsanul Haq Qazi, Chairman IEP, Rawalpindi, Islamabad Center, to please come and receive his memento from Engineer Professor Dr. Sarosh Hashmat Lodi, VC, NED University. Now, I would like to request Engineer Mohammad Murtaza Khurshid, Chairman IEP Multan Center, to please come and receive his memento from Dr. Mohammad Tufail, Pro Vice Chancellor, NED University. Now, I request Engineer Muhammad Afzal, Secretary IEP Lahore Center, to please come and receive his memento from Engineer Professor Dr. Mohammad Tufail, Pro Vice Chancellor, NED University. Now, I request Engineer Group Captain Muhammad Najamuddin, Secretary IEP Islamabad Center, to please come and receive his memento from Engineer Suhail Bashir, Chairman IEP Karachi Center. Now, I would like to request Engineer Suhail Ahmed Khwaja, Secretary IEP Multan Center, to please come and receive his memento from Engineer Suhail Bashir, Chairman IEP Karachi Center. Now, I would like to request Engineer Masood Sheikh, Member Central Council, IEP, Lahore Center, to please come and receive his memento from Engineer Suhail Bashir, Chairman, IEP, Karachi Center. Thank you so much, everyone. Vote of thanks, Engineer Farooq Mohammed Ali. Thank you.
With the distribution of mementos, we come to the conclusion of this inaugural session. I thank all of you for your participation and request you to please join for tea at the staff center. Look forward to see you all tomorrow in the 3 technical sessions, which will be starting at 10:30 a.m. and it will continue up to 3:30. And then at 3:45, we have the closing session. So please join us. You will listen very interesting papers tomorrow. Thank you very much.